In this video, we're going to take a look at practice quiz for standard 14 on trigonometry. Number 1 says to convert the given degree measure to radians. So we're given 150 degrees. To convert it to radians, you just have to multiply by pi over 180 degrees. And then you need to reduce it. Now you can type that in and reduce it with Desmos if you need to, and use the little fraction button to the left of the number. And we can see that that would be 5, so I'm going to put 5 pi over 6 would be the radian measure for 150 degrees. B says convert the radian measure to degrees. So to convert from radians to degrees, you want to get rid of the pi. So put it diagonal from the one that you see, or put it in the denominator if you're going from radians to degrees. So then I can tell that these would be able to cancel out. And I would say now I have 2 times 180 in my numerator, which would be 360. 3 is still in the denominator. And then 360 divided by 3 would be 120 degrees. So that is it for number 1. So notice you have one that goes from degrees to radians and one that goes from radians to degrees. So remember to go from any degree measure to radians. The rule is that you have to multiply by the conversion of pi over 180. So put pi in the numerator. To go the other way and convert from radians to degrees, you got to multiply with pi in the denominator and 180 in the numerator. All right, let's look at number 2. It says find the measure of the indicated side, round to the nearest tenth. So this is one that deals with sine, cosine, and tangent. So remember, sine is some old hippie. So sine of theta is equal to opposite over hypotenuse. Caught another hippie means cosine equals adjacent over hypotenuse. And then tripping over asphalt means tangent of theta equals opposite over adjacent. So if you remember that phrase, it helps you to quickly write those out and remember what you need to do to set them up. So if you look at your angle that they gave you this time and you look at what else is there, you see that you have x, which is opposite of that angle, and you have 13, which is adjacent to that angle. It's not the hypotenuse. So I'm going to put this as opposite and this was adjacent. So then I look over here, which one would make good sense with those, and it would be the tangent of theta. And that helps you to set this up and solve it correctly. So you want to put tangent of theta. Theta is always the angle, whether you're looking for it or they give it to you. So tangent of 32 degrees equals x over 13. And then we just need to solve. In this case, you can just multiply to get rid of 13 in the denominator. And then we'll type that in the calculator. So we get 13 times the tangent of 32 degrees. And then 13 will cancel out. And that'll be our x value. So in your calculator, in Desmos, you can type 13 functions. Go to the trig menu. Click tangent of 32. But make sure it's in degrees, because 32 is in degrees. And so you want that to give you your answer correctly. So 8.12 approximately, or they said round to the nearest tenth, so just 8.1 would be a good answer for number 2. Number 3 comes from the unit circle. That's the day that we practice picking things out from the unit circle. So we just need to go over there and find these exact values. Remember, sine and cosine are coordinated with your coordinates. Every coordinate is x and y. And then in alphabetical order, sine goes with the y and cosine is first. It goes with the x. So if they say sine of 225, I need to find the y value at 225 degrees using my unit circle. So I'm going to go over here and find our unit circle that we worked hard to fill all the things in. Go to 225 degrees on there. So that's right there. And then the y value of that coordinate is what we're looking for. So it would be negative square root of 2 over 2. And that's why they say exact. You don't want a decimal Notice like you can't get that if you type it into your calculator. That's why they say find an exact value, because there's no way to bring that up on your calculator. So don't do that. Then go back to your unit circle and find the cosine, which is the x value at 30 degrees. So if I go over here to cosine of 30 degrees, that's the x value. I find 30 degrees and I can find the x value of that coordinate, which is the square root of 3 over 2. Square root of 3 over 2 is all I need. So square root of 3 over 2. So you'll have a question that asks you for the exact values, and you just want to use the unit circle and pick them out. Do not type them in the calculator. 4 and 5 are graphing ones. So it says graph f of x equals -4 sine of x. So let's type in -4, go to functions, go to trig, click on sine. And you can also type in the word sine. It's just a button in there as well. Then you want to change your window. So you want to hit the little wrench at the top. Change it to match what's on your paper. So you have 0 to 2 pi. So put x-axis goes from 0 to 2 pi. Your step goes with that first thing that they've put there as a label. So that would be step for x is pi over 2. And make sure you click radians, and you should get a pretty good looking graph. And then you just want to plot these points carefully. So let's plot 0, 0. We have pi over 2 goes with -4. So -1, 2, 3. -4 is down there. I'm just going to label that was our step. Pi, notice, is back at 0. 3 pi over 2 goes with 4. I'm just going to make that a little bigger. 3 pi over 2 goes with 4. Let's label that one as 4 at the top. And here I'm going to move this over so I can pick out 2 pi is back down at 0. And then you just want to connect them as best you can. So you go down, back up, and around. And that's it. Let's look at number 5 and graph that one. So if you've typed everything in really well, it'll keep it in there for you when you type this one in. So we got 3. We need cosine of x plus 1. All right, so I've still got my wrench with my basic numbers in there, and you can replace them again, but I can see enough to get everything I need on here, so I don't have to be too picky. I've got 0 goes with 4 this time. So that's 4. Pi over 2 was 1.9 because it got shifted up 1. Everything is shifted up. That's why they look a little different. So 1.9 is about right there. Pi is at -2, which is right here. We have 3 pi over 2 would be 4.37. 0. So that's, let's see. That's just rounding it off. So it just goes with 0. 3 pi over 2 is sitting at 0, in other words. No, wait a minute. Take that back. Let's see. Will it give me that one? That's just another point on the graph, so let's not plot that one. Let's go over here to 2 pi. That's another good one. 2 pi goes with 4. And let's see. We can put these. Pi over 2 was at 1.9. Which is actually the x value. I put it for the y by accident. So pi over 2 is, looks like it's just up like 1 box on my graph. I can just kind of see it right there. Let me show you how I got it. So I can see pi over 2. Pi over 2 goes with 1. See how that dot matches on the graph? And then 3 pi over 2 also looks like it's at 1. And then 2 pi was back at 4. So now we have enough. This is a cosine graph, so I know it's supposed to look kind of like a U-shaped graph. Okay, so that's it for our practice quiz 14.